Hello, this is Mr. Stansbury. I'm going to take you through the 9G assignment. Okay, so first one says, without using your graphing calculator, sketch the graph of y equals x squared on a set of axes and hence sketch each of the following functions stating the coordinates of the vertex. So they really want us to start with the y equals x squared. We call that the parent graph. That's what it's really starting out as. So let's do this. We got x and then y. Right, so normally if we're going to graph some stuff, we just do -2, -1, 0, 1, and 2, right? So -2 squared is -2 squared, -1 squared, 0 squared, 1 squared, and 2 squared. So -2 squared gives us 4, -1 squared gives us 1, 0 squared gives us 0, 1 squared gives us 1, and 2 squared gives us 4. So if we're graphing those things, we've got the point -2, 4. We got -1, -1, 0, 0, 1, 1, and 2, 4. Okay? So then what we're going to try to do, and what I'm going to try to do, which could be difficult, is graph that. And so it looks kind of like that-ish. Okay, so it's parabola. Forgive the kind of not so beautiful lines, but that's roughly what we call that the parent graph. That's what this graph starts as. Okay, and we'll put that same graph over here just so that we can kind of get this thing rolling. Okay, so then we end up with that one over here too. Neither one of those are beautiful, but you get the idea. So now what we're going to do is now we want to graph y equals x squared minus 3. So if we can do this a couple different ways. We can do this with the t-chart. And we get -2, -1, 0, 1, and 2. So we can do -2 squared minus 3, -1 squared minus 3, 0 squared minus 3, 1, oops, that's a 1, squared minus 3, and 2 squared minus 3. Okay, so this one here, 2 squared is 4, -2 squared is 4, minus 3 is 1. -1 squared is 1, minus 3 is -2. 0 squared is 0, minus 3 is -3. 1 squared is 1, minus 3 is -2, and then 2 squared is 4, minus 3 gives us 1. So then if we graph this on the same axes here, we've got -2 now is at 1. -1 is now at -2, 0 is at -3, 1 is at -2, and 2 is at 4. So then now the graph looks like this-ish. Ugh, I have a hard time on this one over here. There we go. Looks more like that. So basically it's just this entire red graph just shifted down 3 spots. Right? So the easy way to do this, instead of making the t-chart, is just to take this whole graph and say it's x squared, but then we're going to subtract 3 from all the y's. So that means you're just going to move the whole graph down 3. Okay? If we use the same idea over here, instead of making the t-chart, we're just going to take our x squared graph, which is the red one, and we're going to move every y value. We're adding 1 to all the y's. So then now, all these points are now up 1 from that. So it looks, oops. In the middle there. We got that, that, and that. So then now our new graph is going to look something like that. So it's going to be just shifted up 1 from that. Okay? Okay. Let's see. Next one. Number 1. Now we're going to sketch the graph of y equals x squared on a set of axes and then sketch these here. So again, if we're just going to copy down our t-chart for x squared, y equals x squared, from the previous problem we did, -2, -1, 0, 1, and 2. So we knew that those are 4, 1, 0, 1, and 4. So if you just -2 squared is 4, so forth and so on. Now if we graph those points there, we've got, let's do this the right way. So we start at -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And we've got that on both of these. So there's negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Okay, so let me take this graph here. And we get that as this original. And let me take this graph here. And there's our other original. And now we're going to see what happens when we get y equals x minus 3 squared. So again, we're not exactly sure what that looks like. So if we're not sure, you can always make a t-chart, right? So negative 2, negative 1, 0, 1, and 2. We're just going to plug all those in. So we got negative 2 minus 3 squared, negative 1 minus 3 squared, 0 minus 3 squared, 1 minus 3 squared, and 2 minus 3 squared. Okay, so 2 minus 3 is negative 2, and negative 3 is negative 5. Negative 5 squared is 25. That's a big one. Negative 1 and negative 3 is negative 4. Negative 4 squared is 16. Still kind of big. Still too big for our graph. 0 minus 3 squared is negative 3. Negative 3 squared is 9. That one will fit. 1 minus 3 is negative 2. Negative 2 squared is 4. 2 minus 3 is 1. Negative 1. Negative 1 squared is 1. Let's do this. Let's do 3. 3 minus 3 squared is 0. That's a nice easy one. Let's try 4 also. 4 minus 3 squared is 1. 1 squared is 1. And then let's add a 5 in there also. 5 minus 3 squared is 2. 2 squared is 4. So just on our graph here, I'm not gonna graph the negative 2 and the negative 1 because it's gonna not fit on our graph. I'm just gonna graph all the rest of these. So we got at 0 we're at 9. At 1 we're at 4. At 2 we're at 1. At 3 we're at 0. 4 we're at 1. And 5 we're back up here at 4. So aha, look, it's this same graph. Now instead of moving up and down, now we're moving it. We move this graph over to the right. And guess how many spots over to the right each one of these points are? 1, 2, 3. It just happens to be whatever you're going to put in for that so that you get 0. So that's, at least that's the way I consider it. So 3 minus 3 will give us 0. So that means we take this whole graph and all of our x values now are moving over to the right 3. Okay, so this one here, instead of making a t-chart, we should be able to say, okay, what minus 1 is going to give us 0? And that's going to be 1. So that means all of these are getting moved over to the right 1 spot. So now all these points here are all moving over to the right 1. So this whole graph is shifted over. Oops, kind of missed that one too. The whole graph is now shifted over to the right 1. Okay? Okay. Moving on to this one here. On separate sets of axes, sketch y equals x squared, and then sketch each of the following coordinates of the vertex. So, I suppose we can graph the plane of y equals x squared. Okay, that's y equals x squared. I'm going to do that on the rest of these here. Okay, so here's our graphs, our y equals, the red things here are the y equals x squared graphs. And now we're going to see what these do. Now again, if we learn from what we did on the previous couple problems here, we know that this here, what minus 1 gives us 0 when x is 1. And then our y is changing to 3. So basically think of this as this x is 1 and this y is 3. So that's the new vertex. So at 1, 3, here's the new vertex because everything got shifted to the right 1 and then up 3. Okay, so from there you go up 1 over 1, up 1 over 1, and then up 3 over 1, up 3 over 1, and then now this graph here is going to look something like that again. So basically the shift, it shifted to the right 1 and then up 3. Okay? So this one here, negative 1 plus 1 is 0, so this is left 1, and it's positive 4, so it's up 4. So we go to the left 1 and then up 4. There's our vertex, and then up 1 over 1 to the left, up 1 over 1 to the right, and then up 3 over 1, up 3 over 1, and then here's our new parabola here. Okay? Same idea with E. Negative 3 plus 3 gives us 0, so it's to the left 3, and then it's negative 2, so it's down 2. That's an O, down 2. That's OW. Gosh, hard to read my writing. So we're going to go to the left 3 and down 2, and there's our new vertex for the parabola. Up 1 over 1, up 1 over 1, up 3 over 1, up 3 over 1, and then this graph's going to look something like that. A little bit less wiggly over here, but you get the idea. Okay? All right. Moving on to number 1, A and E. Write the following quadratics in the form y equals x minus h quantity squared plus k using completing the square, and then sketch each function. So, completing the square. There's we're going to try a little bit different version of completing the square. This is where you're not going to move you're not going to do the first step, which is isolate the constant. We're just going to leave it, and we're going to go straight to step 2, which is take half the x term. So we do negative 2 over 2 is negative 1. I'm going to circle that because we're going to use that later. We do negative 1 squared gives us 1. So that means we're going to add 1 we're going to actually add and subtract 1 from the same side. So we're going to do this. Y equals, here's the different part, x squared minus 2x, and we're going to do plus 1 plus 3, right? And then since we added 1, we also have to subtract 1 to make it even. So we haven't changed anything if we add and subtract the same number from each side. This here now is a perfect square, and then this is going to be our constant that's left over. So we can write this here as a perfect square, and it's going to be x, and remember it's whatever this half of that middle term is, so it's x minus 1 squared, and then we get plus 3 minus 1 is minus 2. So here's our, we've completed the square, and we now have it in the form that we were just looking at in the previous problem. So now we can figure out the vertex. We're going to go 1 plus 1 minus 1 gives us 0, so to the right 1. And then this says down 2. So we're going to go to the right 1 and down 2. There's our new vertex. Up 1 over 1, up 1 over 1. And then we can go up 3 over 1, up 3 over 1. And then we're just going to sketch our parabola here. Okay? So that's what that one looks like. All right, let's take a look at this one here. We've got y equals x squared minus 4x. There's not even a constant to have to worry about anyway, so we're still going to take half of negative 4, which gives us negative 2. We're going to take that negative 2 and square it, and that gives us 4. So we're going to add and subtract 4 from the same side. So we get y equals x squared, let's see, minus 4x, that's this here. And then we're going to add 4 and also subtract 4. Okay, so this here now is a perfect square, which is going to be x squared, and it's going to be minus 2, and then we got minus 4. So then that makes this a much nicer one to graph than what we have here. Okay, so this tells us to go to the right 2, and then the negative 4 tells us to go down 4. There's our new vertex. Up 1 over 1, up 1 over 1, up 3 over 1, up 3 over 1, and then sketch our parabola. Okay? Okay, moving on. Next one, sketch the graphs without tables and state the coordinates of the vertex. Okay, so let's do this. Let's state the coordinates of the vertex and then graph it. So vertex is going to be whatever makes this equal to 0, which is 1, because 1 minus 1 is 0. Ignore the negative out here. So 1 minus 1 is 0, and then plus 3. So our vertex is at 1, 3. 1 and 3. Okay, now here's something that's a little different. Since this is negative, think of this as negative 1. So instead of going up 1 over 1, we're actually going to go negative 1. We're going to go down 1 over 1. So we go down 1 over 1, down 1 over 1, and then we go down 3 more over 1, down 3 more over 1, and then our parabola looks something like that. Okay, so the negative just flips it over. It opens down instead of opening up. Okay, vertex here is at 2, because 2 minus 2 is 0, and 4. So we go over 2, up 4. And again, this is negative 1, so we're going to go down 1, over 1, and then down 3, over 1. Oops, let's see, I think I went too far. Yep, that should be this one right here. So let's do that again. Okay, down 1, over 1, down 3, over 1, and then there's our graph there. Okay, this one here, vertex. This is an interesting one. I like this one. Negative 3 plus 3 gives us 0. And now there is no y out here, so we can just put this, that's the same thing as plus 0, so our y is going to be 0. So we're actually starting now at negative 3, 0. And then, since it's a quadratic, not a linear, what we want to do is you always want to put, even if it's a fraction, put it over 1. So the next point is going to actually be down a half over 1. Down a half. Oops, sorry, it's positive 1/2, so it's actually, going to be up a half over 1, and then up a half over 1. And then it would, since the next one was 3, so then it would be up 3 halves, so a 1.5 over 1, and then up 3 halves over 1. So then our parabola is going to look something like this. So now with that 1/2 actually has made the graph wider. It's a wider parabola. Okay. All right. Sketch the following functions without using tables of values and state the coordinates of the vertex. We can do that. Vertex. Negative 4 plus 4 is 0. Positive 3 for the y. So we're at negative 4, 3, which is right there. And then now this is negative 2 for the slope on this thing. It's negative 2 over 1. So we're going to go down 2 over 1, down 2 over 1. And then since it was, we actually go down 2. Remember how the next one from there we go up 3 over 1? You go up, you go 3 times negative 2 is actually down 6. So down 1, 2, 3, 4, 5, 6 over 1. And really down 1, 2, 3, 4, 5, 6 over 1, and we're good. I'll be honest with you. If you get, as long as you get these first 3, the vertex, and the next points after, that's just fine. You don't have to worry too much about those other points. Okay. This one here, vertex, is at 3, because 3 minus 3 is 0, and 5. All right. So we're over at 3, up 5. And then the slope to the next point is up 2 over 1. Up 2 over 1. Okay, and then we just make a curvy line from there, and we call it good. Okay, and there's our new graph. All right. Last one, we're going to do these two here. So vertex is 2 minus 2 is 0, so we're at 2 and then plus 1. So we're over 2, up 1, and then we're going to go from there up a half over 1, up a half over 1 this way, up a half over 1 that way, and then we just sketch our now wider graph there. And then this one here, vertex, is going to be negative 1 plus 1 is 0, and then negative 4 for our y shift, right? So these really are our shifts over here. So we're negative 1, negative 4, and then from there it's down a half because it's negative 1/2 over 1. So we go down a half over 1 here, down a half over 1 here, and then we make that wider parabola because it's that number here is between, it's greater than negative 1 but less than positive 1, so it means that the parabola is going to get widened out. Okay, all right, that's all there is for 9G. If you have any other questions, please feel free to ask in class. Thanks.